Good evening! We're doing electricity again, this time more properly. So listen up because we're learning about lightning. The broadest definition of lightning is an electric discharge between two areas. Bolts can form within a cloud, between two clouds, or of course between a cloud and the ground. Well, you should understand ground as including anything on the ground like a tree or building. Now, the way lightning forms is still not fully understood by science, but a lot is known. Within a cloud, ice and water particles will move around. The collisions make them trade electrons, gradually building up a negative and positive charge in there. The most active area for those interactions is in the center of a storm cloud, where there is an updraft and temperatures are about negative 20 degrees Celsius. Small ice crystals and water droplets, which are light, travel up and give their electrons away. Heavier particles, known as soft hail, move down and become negatively charged from the other particles' electrons. So over time you get a high concentration of electrons at the bottom of the cloud, and they either get attracted to the top or try to go for the ground. The air is rather resistant to electricity, so it tends not to travel through it. But as soon as there is a big enough potential difference between 2 points, the energy is used to bridge the gap. But it's not a simple kaboom. This process still has a few steps. Ionized air channels, called leaders, start on both ends. The upward and downward leaders will be attracted to each other, accumulating charge after about 45 meters, from which they burst into branches. Attachment is the state in which two leaders connect and is not always necessary for the discharge to occur. Yeah, I told you we didn't understand everything. So, now that there is a low resistance path for electrons to move along, they'll just go for it. As fast as 1/3 the speed of light. The initial strike, called the return stroke, sends electrons over to balance the charges. The energy from this quick event superheats the air, over 50,000 degrees, turning it into a glowing plasma. The sound happens because this makes the air explode, since the sudden heat difference forces it to move real quick. This all takes place and dissipates in no more than a few tenths of a second. Then, different parts of the cloud will use the same channel to send re-strikes. There can be a few of those, up to 30, but since they're separated by only a few hundredths of a second, we tend to only see one strobe-like flash. Nature sure is awesome. Alright, I've gone on for long enough. Good night, everyone.